Bismillahirrahmanirrahim. Today we will see the equivalent circuit with respect to the source's point of view. Okay, so when you view from source perspective, what are the equivalent circuit corresponding to a current source and a voltage source? Okay, let us assume that we have a current source. You have a current source like this. Let's say this is the current source is. Okay, now suppose I connect a resistance in series with a current source. Okay, in series with the current source. So you can see this is the resistance in series with the current source. However, and this R1 is not equal to infinity. It is not equal to infinity. In this kind of cases, actually this is equivalent, not equal. I am not saying it is equal, but it is equivalent to this because it is something like this. It is because your R1 is not equal to infinity. That is one reason. And also this is a current source, and this current source will never get affected by this guy because this R1 will never influence on is. That's why I can remove this R1. However, there is a problem during the power calculation. So during the power calculation, so during, if you want to calculate the of the circuit, total circuit, so during the power calculation, you can't remove. Okay, you can't remove. So because you have to include, because there will be some power dissipation across this R1. However, if you are calculating the current, so during the calculation of current, okay, during the calculation of current, you can say, or you can say, if you are writing the Kirchhoff current law, you can remove it. Okay, you can remove it because it is a current source, and nobody will influence this current source, because if this is 3 ampere from is, then if you connect R1 or not, it will be 3 ampere. But if R1 is infinity, the situation is different. Okay, if R1 is not equal to infinity, this will be the case. I hope that you understood this, right?
But there will be a voltage drop across R1, right, doctor?
Yes, voltage drop is there. Voltage drop will be there. But during the current calculation, that's what I told you. During calculation of the current, or you can
Okay,
say if you write the Kirchhoff law, you can remove this. Okay, no issue. I hope that this is clear to you, right? So
yes,
similarly,
yes.
if we take a voltage source, if you had take a voltage source, okay, and you can see this is R1. Okay, this R1, I will change the color to have a better understanding. So you have a R1. So in this case, actually it is equivalent to something which is just a voltage source. This is a voltage source. This voltage source, you can say Vs, like this. So this is equivalent such that your R1 equal to 0 here, you can see. If R1 equal to 0, then it will be a short circuit, and there will be a lot of issues that we will discuss later anyway. So here in the voltage calculation, in the voltage calculation, sorry, in the calculation, voltage calculation, you can remove, because the voltage in parallel, that will be same if you connect R1 or not. But in the power calculation, you can't remove it. You can't remove. Okay, you can't remove, because In the power calculation, there will be some power absorption across the resistance. Okay, the resistance will usually absorb the power. Okay, so this is the case. I hope that you understood this point, right? It's clear to you?
Yes, doctor.
Okay.
Yes, doctor.
Next, we will
Yes,
see
doctor.
very important point. Very important point. Okay. Let us assume that we have a current source like this. Okay. Let's say this is I1 and this is 3 ampere current source, and you have another connection which is I2. This is 2 ampere current source. Then what will be the total current?
5.
Is it 5?
Is
What will
this
be the
an
total
open
current?
circuit or just for
Okay, whatever.
any?
You connect a load, no problem. Okay, you connect a load RL, no problem. Okay, what will be the current?
1.
5.
There is a problem with this circuit. Okay, this circuit, I will say this circuit is a circuit which does not exist. Does not exist means you cannot connect a circuit like this. If you connect a circuit like this, then sometimes it will lead to instability and sometimes it may heat up and burst. Okay, it is because you take any node here. Can you tell me what are the nodes here? You can say here, I can take a node here. This is a node, right? This is a, you write the Kirchhoff
Yes.
law, and from the node you can see I1 is going away from the junction because this guy is going away, and it is coming into the node, coming in. So if it is going away, I told you we have to assign positive sign. I have already told you. And if it is coming in, I have to assign negative sign, right? So I will write the KCL, Kirchhoff current rule. Then it is plus I1, then minus I2, right? Equal
Right.
to 0. This is the KCL. I will just write this. I1 is 3 ampere minus 2 ampere, but this is 1 ampere. Is it satisfying the Kirchhoff law? It is
No.
not satisfying.
Oh.
It is not satisfying the KCL. So if a circuit does not satisfy Kirchhoff law, then it will not exist. If you connect the battery or a current source, whatever, so usually the battery will be voltage source. The current source will be usually made using the transistors and all. But if you connect something like this, it will be a big problem. The circuit will get heat up and it will damage completely. Okay, it will completely damage. Then we will see, but we can connect this in some occasion. When do we can connect this? Can you tell me? We can connect this in some occasions.
In parallel.
No. I am not going to change the structure of the circuit. You can connect this circuit. You can, so here in the previous case you can have no connection. Okay, so you can connect like this only if
we have a resistor.
no, only if I1 equal to I2. You understood? If I1 equal to
Yes.
I2, then it will
Yes.
satisfy the Kirchhoff law, no problem. So in this kind of occasion, you can say you can say that you can connect the circuit. So if I1 equal to I2, you can connect the circuit. Otherwise, you can't. Okay, the circuit will not exist. Now we will see other. Assume you have a connection, something like this, a voltage source V1, and you have another voltage source which is V2. What about this connection?
It will be the same problem, except if V1
Yes.
equals V2.
So I will write the Kirchhoff voltage loop here. Okay, I will take the loop here. So since I am starting here at this point you can say it is minus, so minus V1, right? Now when I go here, you can say this is plus, so plus V2 should be equal to 0. Suppose this is 3 volt and this is 2 volt, then minus 3 plus 2 equal to 0. It is not satisfying. So this is the problem. Okay, it is not equal to 0. So it do not satisfy KCL. Sorry, not KCL, KVL. Okay, Kirchhoff voltage law. So it does not satisfy. So it does not exist. This kind of circuit does not exist. It's very important point. Don't forget this. Okay, so the circuit does not exist. So if you take a 12 volt battery, you can consider, you know that in your car the battery is giving you 12 volt. You take a 12 volt battery and connect in parallel with it another 1 volt battery, 1.5 volt. You can get it from a AA battery, you can say. You can get the supermarket. If you connect like this, what will happen? Your big battery, actually the car battery, will load, it will give some high current to your 1 volt battery, and sometimes it will burst. It will burst and it will harm you. Okay, so don't connect like this. So if you are connecting the voltage sources in parallel, you can connect the voltage sources in parallel. You can connect the voltage sources in parallel only if your V1 is equal to V2. If V1 is equal to V2, you can say this is V1, let's this is equal to 3 volt, and you have another connection which is equal to V2, which is equal to 3. No issue. So both voltages, if both voltages are in parallel, sorry, both voltages are same, then you can connect. So this is very important point. I hope that you understood this. Okay. Yes, this is very important point. Don't forget this. Now we will see another connection. Assume that you have a connection like this. You have a voltage source. Let's say this is V1, another voltage source which is V2. Now you want to measure what is the total voltage. So for voltage, you can say this is VT total or V total. I am just assigning some sign, positive and negative. You can assign any sign, positive or negative, whatever. If you assign a sign positive and negative like this, and if you get a positive answer, then your assumption is correct. If you get a negative answer, the actual polarity will be just opposite to your assumption. Okay, now I will write the Kirchhoff law here. So I will start from here. So you can see I have a minus, so minus V2. Next I have a minus, so it is minus V1. Next, if I go like this in clockwise direction, I have a plus, so plus V total. This is equal to 0. So V total will be equal to V1 plus V2. So this is like the connection. Okay, the connection is like this. Now if you change the polarity according to that, it may be V1 minus V2 and V2 minus V1 if you change the polarity of each. Okay, so this is the connection if you connect the voltage sources in C. Now assume another connection. So we will see every type of connections, so then only we will solve the problem, otherwise no use. So this is I1, This is another current source, I2. Can you tell me what will be the total? Let's say this is I. If you connect a load here, assume you have a load, anything.
plus I2.
Yes, very good. And how we will get it? We will apply the KCL at this point. You can see here this current is coming into the node. This current is I2 is also coming into the node, and this guy I is going away from the node. So I will assume minus I1 because it is coming into the node, plus, and it is coming into the node, I will assume minus I2, or I can say, yeah, in the same way. Then you can see here it is going away from the node, so it is plus I, sorry, not I1, plus I. This is equal to 0. So you can see that I is equal to I1 plus I2. So this is how we will calculate. So if you connect two current sources in parallel, the total current will be the sum of the two currents. But if you connect like this, one current is I1, okay, and this is going down, which is I2, then what will be the total current? This is I will be equal to I1
minus I2.
minus I2. Okay, so it is clear from the simple observation. You don't need the KCL at all. Okay, it is very clear from the just simple observation. Okay, with logic it is very clear. Okay, next we will see here one more thing, another case in the previous example. I will just assume this is a case 1, I can say. This is case 2. I have plus, this is V1, but I just change the polarity for V2. Then the total voltage I am saying, this is V total. Then without anything you can say V total is equal to how much?
V1 minus V2.
V1
V2
minus
minus
V2. V1 minus V2 if I assume the polarity like this. Okay, V1 minus V2. If I assume the polarity like this. Now we will see the case here. Example, let's say if I connect here 2 volt and another battery which is 3 volt here, then you will get, I assume this is positive and negative, this is V total. V total is V1 minus V2, 2 minus 3. I am getting minus 1 volt, right? Then what is the meaning? The meaning is that since I get the minus sign here, the actual polarity is minus here, and the actual polarity here it is plus. You understood the point what I'm saying? Got it?
Yes.
Yes, this is what I want to convey to you. Okay, now we will see a problem. So so question 1. So determine, you have to find, that means determine the current through 5 ohm resistor, okay, in the circuit. Okay, I have a circuit like this which is plus 5 volt here, and I have a 5 ohm, and I have a 10 volt here. Then what will be the current through this 5 ohm resistance? This current I
15. 15 ampere.
15 ampere. How did you get it?
Oh, I thought it was current source. It will be.
No, it is voltage source. Okay, voltage sources. Can you observe something? I will redraw the circuit. I will redraw. This is my answer.
How can it be the voltage sources are not equal?
Yes, that's very good answer, because this kind of circuit does not exist. I will redraw the circuit again. because this is the question I just given you to confuse. That's why. You can see here, I can redraw. Is it same? Please tell me, is it same or not?
Yes,
Yes,
it's
same.
same.
We apply KVL.
Yes.
What
If you take the
one?
wire and put it here, you can redraw the circuit like this. Is it same? Same, right? Is it same?
Yes. Yes.
So you can see two sources, one is 5 volt and one is 10 volt, are in parallel. That is 5 volt and 10 volt in parallel. It is not possible. We just discussed now. So this kind of circuit does not exist. If you connect like this, your battery, everything will damage. Okay, does not exist. Okay, you cannot connect it like this. Clear? Because it does not satisfy the Kirchhoff voltage law. Okay, I'm not going to apply the Kirchhoff voltage law because you know this. So physical connection is not possible. This is my observation. So the physical connection is impossible. I hope that this is clear to you, right? Shall I
Yes,
move?
Doctor.
Okay.
Yes.
Yes,
These
yes.
are all the very fundamental and important concept. Don't forget these things in your life, okay? Because if you don't know this, you cannot solve any circuit. These are all very, very important points, okay? Next, another circuit, okay, question number 2. Another circuit, you have a, that I will come to that later because it needs another kind of theorem, which is superposition theorem. I didn't taught you. So we will see a circuit. You have a current source, which is 3 ampere, and you have, this is 2 ohms. You want to find what is V naught. This is minus, and you have another current source, which is 2 ampere. Then what will be V naught? This is the question.
It does not exist, the circuit.
Yes, the same thing. This
That's fine.
problem, okay, this not possible. So it does not exist. This physical connection is not possible, does not exist. Okay. So these kind of questions you can see in competitive exams because you can answer within 1 second or 2 seconds if you know the concept. Otherwise, you will apply the Kirchhoff law and waste your time. You understood? That's why they put this kind of questions in the competitive exams. Okay.
Yes, yes.
So be careful these kind of things. Okay. Next, we will see another very, very important thing, which is known as the Teligens's theorem. Okay, have you heard this before? Teligens's.
No, Doctor.
I didn't.
Okay. So I am going to write the theorem. This is the statement for this theorem. In any linear network, okay, I will just network. I will be writing like this: NW, N bar W. In any network, the algebraic sum okay, of the powers, we are talking about the power. Okay, so the Teligent theorem is talking about the power. Okay, it is talking about power. Okay, so the algebraic sum of the powers at any given instant, this is very, very important statement. Given instant means at any time, okay, irrespective of time. If the circuit is linear network, the algebraic sum of all the powers at any given time, given instant, okay, a given instant is 0. Okay, that is given 0. That means if you have if you are supplying the power you can say that it is a positive power. If somebody is absorbing the power, you can say it is negative power. So if you add all these powers, that means total power supplied and total power absorbed, the sum of all these things will be equal to 0. Okay, we will come to this later anyway. So that is the power delivered, okay, by some components, some elements is equal to the power absorbed, okay, the power absorbed by remaining elements present in the circuit, okay, or present in the network. I hope that this is clear to you. The statement is clear to you, right?
Right.
Okay, next point is very, very important point. If the current enters the negative terminal, okay, I will just write it, negative terminal, okay. If the current enter, please note this point, negative terminal, if the current enters the negative terminal, then that negative terminal of an element, okay, it is understood, then that element will deliver the power, okay, it will deliver the power, you can say, sorry, it will deliver the power, okay. Otherwise it will absorb, okay, absorb the power. So what does it mean? Suppose you have a voltage source, something like this. This is a voltage source, let's say it is Vs, and you have a lot of things. You have a resistance, for example, let's simple circuit we can consider. Now you can say that the current will start from positive and it will go to the negative. Now you can see here, the current is entering the negative terminal. Is it clear? Is it clear to you? The current is entering the negative terminal.
Yes.
So if the current is entering, your Vs is supplying, he is delivering, okay, your Vs is delivering the power, because who is supplying the power here? Vs, because the current is entering the Vs, okay, entering the negative terminal. That's why, so the current is entering the negative terminal. So Vs is a source, and this source is giving the power, he is delivering the power. A source can absorb and deliver the power. The source can do both things, okay, that we will come to the next point. So the next point,
deliver the power to the
yes,
to the circuit.
yes. So the power Vs, that is the power delivered by the Vs, okay, this power across the Vs is nothing but he is delivering. And who is absorbing here? Who is absorbing? You can see here, this is positive and this is negative. So you can see the current is entering which terminal? Positive. The current is entering positive, right? So the power across RL is nothing but this guy is absorbing the power. You understood the point? Now,
Yes, doctor.
now we will say the Telegen's theorem. What does it means? Now you can see here the power delivered will be equal to power absorbed. Or I can say for delivering, if I give positive sign, then for absorbing I can give which sign?
Positive.
Negative. That means the power delivered plus the power absorbed, and power absorbed I am giving negative sign. This total
It can
will
be
be equal
the opposite, right? It's okay, right?
it's okay, it's okay, but I am giving you delivering means you are delivering something means positive. If you absorb,
You
you
are
can say it is any sign you can give. Okay, just should be opposite. Okay, no issue.
Okay.
It should be total will be equal to 0. You understood? Assuming
Yes.
there are no losses. Okay, whatever losses is also there, if we consider, then also it will be 0 total. So there is one important point. A source can absorb. Okay, a source can do both things. In the above case, the source is delivering, but a source can absorb or it can deliver we will see that those examples later. So a source can absorb or deliver power. Okay, this is very, very important point that you have to remember. So a source can do both things. It can deliver or absorb power. So if you have a voltage source, sometimes it will deliver the power. Can you tell me when it will deliver? For example, if you have a car battery, if your car battery, when the car is off, when the car is not started, okay, maybe your battery is on, everything is on. If you turn on the headlight, then what your battery is doing? Your battery is delivering the power. Am I correct?
Yes.
Yes. But when you start the engine, then what will happen? Your alternator or the dynamo will work and it will
Give power to the
battery. Now the battery is absorbing the power. I hope that this is clear to you, right? Yes. Yeah, that's
Yes,
what
yes.
I am saying. Okay, now we will see the features of this Teligent's theorem, some more features of Teligent's theorem. So very, very important features. So this theorem, features of Teligent's theorem. Okay, Teligent's theorem. I will use, okay, Teligent's theorem. I will use just TT. Okay, TT for Teligent's theorem. I don't want to write the entire thing again and again. So the theorem depends, actually it depends only on voltage and current. Okay, it will depend only on the voltage and current product. Okay, the product of voltage and current, that means this is nothing but the voltage into multiplied by current. Okay, but not on the type of element. Okay, element, it can be active element, you know what is active, or passive element, because this is a very strong theorem. It is applicable for active and passive. That means you can apply this for solving the circuits like the transistor circuits, everything, because transistor circuits are usually active circuits. So you can use it there also, there is no issue. That is independent, okay, independent of the nature of element. Okay, it does not depend upon which type of element. Okay, you can apply it anywhere. Okay, that is one of the very, very important point. And this is actually showing the law of conservation of power, law of conservation of power, sorry, the law of conservation of power, conservation of power. So that means the power delivered will be equal to the power absorbed. I hope that this is clear. This statement is very clear to you. It's clear?
Yes. So the total power will be
Yes,
equal.
So if a battery is delivering some 20 watts, then there will be other elements which will be in the circuit which may absorb in total 20 watts. Okay, that's what the theorem is saying. Now it is very logical. Okay, but it is very powerful theorem. You have to note that it can be applied for solving your transistor circuits, that is active circuits also. That is the very interesting fact. Okay, now we will see another circuit. Okay, I will write, just assume a circuit. You have a circuit like this, a 20-volt battery, and you have a resistance of 5 ohm. Okay, and you have something like 5 volt. Okay, and this is connected like this. Okay, can you tell me what will be the current here? If I assume the Kirchhoff law, I can assume the Kirchhoff law like this. Okay, we will write the Kirchhoff law. Let us assume that I have a current I. Okay, I will write
Doctor, there is
like
a
this.
problem.
Yeah.
It is not satisfy Kivil.
Why?
Oh no, I'm sorry. I thought it is.
Okay, be very careful, because the voltages, where there is a resistance in between, that's why if you put a resistance in between, it will manage it, everything. Okay, but if the resistance is in parallel, you cannot connect, but in series there is no problem. Okay, be thorough with that thing. Okay, don't forget. Now we will see, this is minus, this is plus, so I start from here, minus, so minus 20 volt. Okay, and I have a current like this, so this is plus and this is minus. I assume like this, and if I get the positive answer, if I assume the direction of the current like this and I get a positive answer, that means my assumption is correct. Otherwise my assumption is wrong. That means I have to take the direction of the current in the opposite way, but I am assuming the current in the clockwise direction, so it is minus 20 volt. Then again it is plus I into 5 ohm. Okay, I into 5 ohm, then plus, right, plus 5 volt, this total equal to 0. I am just writing the Kirchhoff law. Now you can see here minus 15 volt plus I into 5 ohm equal to 0. That means my I equal to 15 volt divided by 5 ohms. This is equal to 3 ampere. So my current is 3 ampere. This is correct. My assumption is correct. I am getting a positive answer. So my assumption is correct. So my current is in this direction. So, and how much is the current? It is 3 ampere. So my current is flowing like this, flowing like this, flowing like this. Now, you know that the total current in the circuit, in the overall circuit, you can say it is 3 ampere. Now, can you tell me what is the power across the 20 volt source? How much will be the power?
60 watt.
Yes, you have 20 volt multiplied by 3 ampere is flowing, so it is. Can you tell me whether it is absorbed or delivered?
It's delivered.
Yes.
It's absorbed,
Why?
Doctor.
Can you tell me
The
the
current
reason?
is entering the negative
Because
side.
of the resistance, it supplies current to the
Please see
resistance.
the direction of the current. Please see the direction of the. Please see the direction of the current. The current is
Because
entering the
it
negative
enters
terminal.
the.
I told you in the previous. I told you this one. You remember? If the current is entering the negative terminal, the source is delivering the power. I told you. It's clear?
Yes.
Or I can say in another way, the current is going away from the positive terminal. Okay, if the current is going away from the positive, or I can say the current is entering the negative terminal. Both are correct. Okay, so this guy is delivering the power. Okay, it is delivering the power. So 20-volt battery is delivering the power. Next, what about the 5 ohm resistance? We will see what is the 5 ohm resistance. Yes.
For delivering, I think
Yes.
minus sign is more accurate, because minus refers to giving something or lose something. So it's
No,
lose
here this
power.
minus sign, I didn't include any minus sign. Okay, here in this case I didn't include any minus sign. Okay, delivering, and I just given this sign in the previous thing just to understand. You can assume in another way also, or you can assume here negative and this as positive, no issue. Okay,
Okay.
it's clear. But
Yes.
but this point is very important. That means if you have a source, you can see my marker. Okay, if you have a source Vs, and if the current is entering the negative terminal, or if the current is leaving the positive terminal, then Vs is delivering the power. That you should not forget. Okay, so the 5 ohm resistance, what will be the voltage across the 5 ohm resistance? Can you tell me what will be the voltage across the 5 ohm resistance?
3
Minus
multiply
15.
5 squared.
Yes, it will be 15 volt, right? So the voltage will be 15 volt. So I will just take the voltage as 15 volt.
Power
And
or voltage?
I am just talking about the voltage, is 15 volt.
Okay.
And what is the current? The current is 3 ampere, same current. So it is 45 watts. And you can see here the current is entering the positive terminal, or it is going away from the negative terminal. So this guy is absorbing or delivering? Yes, it is absorbing the power. I hope that this is clear. The concept is very clear to you, right? Now we have a 5 volt battery. So we have the voltage as 5 volt and the current as 3 ampere. Now you see here it is 15 watts, and this current is going into the 5 volt, or it is going into the positive, or it is leaving from the negative. So it is absorbing or delivering? Please.
Absorbed.
Okay, now you see the total. You can see here this is 60, and what about this? It is 45. 2 absorbing, 45 plus 15 is 60, and delivering is 60. So you can see it is very satisfying the Teligent's theorem. Is it clear to you? So total delivering is equal to total absorption. Okay, so this is what I want to tell you. It's clear. Power delivered is equal to power absorbed, or I can say 60 watts is equal to 45 watts plus 15 watts. This is absorbing, you can say absorbing, and this is delivering. Okay, I hope that this is very clear to you, right? I will move on to the next problem. We will see a lot of problems today. It's clear? Excuse me.
Yes, doctor.
So we will see another problem. That means I am just going to write like this. Question 1. Verify Teligent's theorem. Okay, so VTT. Okay, this is my short form. So in the next problems I will be using VTT, verify Teligent's theorem. Now the circuit is like this. You have a 2 ohm resistance, you have a 2 ampere power supply. Okay, you have a 2 ohm resistance and 2 ampere power supply. Then you have a resistance of 2 ohm again. This is here, and you have a 2-volt battery. Okay, now we have to find out the power across all these components. That means we are going to verify the intelligence theorem. So for example, the power delivered by the 2 ampere current source, what is the power across the 2 ohm resistance? Okay, the power 2 ohm resistance, that means let's say this is R1 and this is R2. Let's say this is R1, and what is the power across the 2 ohm resistance, which is R2? Okay, and what is the power across the 2-volt battery? This is what first of all we want to find out. Okay, so can you tell me how to proceed for this problem?
We will
Excuse me?
calculate the power of the first
Yeah,
resistance
first
on
of
the
all we
left.
want to we want to first of all we want to, you know, that this current is going here like this. So it is plus, this is minus, and the current is 2 ampere. Am I correct? Yes. And you know this
Yes.
voltage is plus and this is minus 2 volt. So R2 is in parallel with 2 volt. So the voltage across R2 will be how much? Voltage across R2 also will be 2 volt. Am I correct?
Yes.
Now, since the voltage across R2 is 2 volt, what will be the current through R2? The current will be
1.
yes. You see here, yes. I am marking the direction like this. It is because I am marking the current direction from positive to negative. Okay, it will be always like this. So the current will be 1 ampere. Am I correct? Now what will be the current through this path by using Kirchhoff law?
1.
Yes, 2
2
ampere is
through 1.
coming inside. Yes, it will be 1 ampere. So it's very simple problem. That's why I'm not going to apply the Kirchhoff law in detail. I'm not writing the steps. So from the simple observation, it is very, very clear to you. So it is 1 ampere. Now we can find out all the power. Now you know that this is 2 ampere for R1. I'm talking about R1, 2 ampere. So for R1, how much will be the voltage across R1?
4.
2 ampere into, yes, it will be 4 volt. Okay, it will be in this direction. Okay, 4 volt. What will be the voltage? Okay, this is 2 volt anyway. You know this voltage is 2 volt. It's very clear. So what will be the voltage across the 2 ampere current source? We will write the Kirchhoff law to find this. I will just write the steps. So you can write the Kirchhoff law for this KVL here. So the voltage, you will assign some polarity here, some polarity. Say this is the voltage across the source, Vs. Let's say this is Vs. So I will just write the Kirchhoff voltage law around this loop 1. So this is loop 1. Then it is minus Vs. Okay. Then you can see another voltage is plus 4 volt. Then plus 2 volt. That is the loop or the mesh, you can say, is equal to 0. So what is Vs? Vs will be equal to 6 volt. So what will be the voltage across the, what will be the voltage across the current source? It will be 6 volt. Now you know what will be the power, what will be the corresponding power. We will calculate what is the corresponding power. So 6 volt, you know, and
or just
apply the KVL
to the outer loop that contain the 2
no, you just apply the Kirchhoff. No, don't apply the Kirchhoff law like that. Okay, you can apply the Kirchhoff law like that also, no problem. Usually we will assume the mesh. Okay, mesh analysis is more comfortable. That's why. Okay, if we take a loop, then it is sometimes it may complicate. Sometimes, not in all cases. Sometimes. Okay, so 6 volt multiplied by 2 ampere. So it is equal to how much? It is 12 watts. Now can you tell me the polarity here? You can see it is minus. So the current is going inside. So it is absorbed or delivered?
Delivery.
What it is? Yes, it is delivered. Okay, I will just write DEL. Okay, delivered. Now for R1, you know the voltage across R1. That means I am talking about the second one, the power by 2 ohm resistance. It is 4 volt multiplied by 2 ampere. So it is nothing but 8 watts. And you can see the resistance, and the current is going away from the negative terminal. So it is absorbed. Now we will take another one. Next one, 2 ohm R2, the resistance R2. You can say the voltage is 2 volt multiplied by 1 ampere. I think so, right? So it is 2 watts. And what is absorbed or delivered? The current is going away from the negative terminal. So it is absorbed. Okay. Now we will see the 2 volt source. The current is going inside the positive terminal, or it is going away from the negative terminal. So again, it also will be actually absorbed. So it is 2 volt multiplied by 1 ampere. It is 2 watts. So you can say it is absorbed. Okay. I hope that this is clear to you, this problem. Okay. So next we will see another problem. Okay. Verify Tilligan's theorem. Okay. I am just writing like this. Verify Tilligan's theorem, VTT. Okay. So please understand what is VTT. Okay. Next we have a voltage source which is 3 volt, and you have a resistance which is 4 ohms, and you have a current source like this which is 0.25 ampere. Now we will see what is the power. The power across 3 volt resistance, 3 volt source. What is the power? What is the power across the 4 ohm resistance? And another component is the current source. What is the power across 0.25 ampere current source? Okay. So these are the things we are going to find out. So before that, we want to know everything. What is the current? What is the voltage? So I am, first of all, you know that this 3 volt, this 4 ohm resistance is in parallel with the 3 volt. What will be the voltage across 0.25 ampere current source? What will be the voltage?
3.
Yes, I have given the point in the last class, because the voltage across a current source can be any value. It will depend upon another elements in the circuits. Do you remember this point?
Yes.
And for the voltage source, the current through the voltage source can be any value, and it will depend upon another elements in the circuits. So don't forget this. Okay. So the current source means its voltage can be any value. It will depend upon other guys. Okay. Another things in the circuits. So we will first focus on the voltage source. So according to that, the voltage across this is also 3 volt. So what will be the current here? The current will go from positive to negative. So the current will be 3 by 4 ampere. Am I correct?
0.5.
Yes. So since this is 3 by 4, means it is nothing but 0.75 ampere. 3 by 4 is 0.75. And you know that this voltage is positive across the 4 ohm resistance. So the voltage across the current source will be also 3 volt. I hope that is clear to you. Now the current through the current source, that is nothing but 0.25 ampere. So according to the Kirchhoff law, what will be the total current coming in? You can see here 0.75 is going through 4 ohm resistance, and 0.25 is the current source. then what will be the current? 1 ampere. Am I correct? It will be 1 ampere. Yes. Now you can see this current is coming like this. So this is going like this. Now I can say the 3 volt, what is the power across the 3 volt battery? It is nothing but 3 volt into 1 ampere. It is nothing but 3 watts. Can you tell me, is it absorbed or delivered?
Delivered.
Delivering.
Yes, because the current is entering the negative terminal. You can see this is negative and this is positive, and the current is entering here. That's why it is delivering. Okay, be careful regarding this. Now regarding the 4 ohm resistance, the current is going down or it is going away from the negative terminal, so definitely it will be absorbing. Okay, and you know the voltage is 3 volt and the current is 0.75 ampere. Okay, so 3 into 3 by 4 is actually, it will be 2.2 watts. You will get it as 2.25 watts. And what about the 0.25 current source, ampere current source? It is nothing but you have the voltage is 3 volt multiplied by 0.25, so it is nothing but 0.75 watts, and it is absorbing. It is because the current is going away from the negative terminal. You can see the current is going away from the negative terminal. That's why it is absorbing the power. Is it clear?
Yes, doctor. Doctor, can we
So
have
next
two
we will,
sources that deliver power?
sorry, yes, we can have.
Can we have two sources that delivering power?
Yeah, it will be there. It will be there in some kind of circuit. We will come to that example. Okay, after a few minutes, inshallah. Okay, we will come to that example. Okay. Question number 3. It is verify Telegen's theorem. So there is a 10 volt battery. Next, we have a current source. And we have a resistance. Which is 5 ohms. Okay. Now we want to verify the Telegen's theorem. We have a 10 volt battery. How much power across this 10 volt battery? How much by this 2 ampere current source? And how much by this 5 ohm resistance? That's what we are going to find out. Okay. Now for that we need some ideas. You know that what will be the voltage across the current source? Can you tell me what is the voltage across the current?
Same the voltage source.
Yes, that's what, this is the main point first of all. So this is 10 volt. Now what will be the voltage across the 5 ohm resistance? It is also 10 volt.
Same.
Yes. Now what will be the current through this? Current will flow from positive to negative, so the current will be 2 ampere. Am I correct? Yes. Now you know that this 2 ampere is coming here, 2 ampere is going away. Okay, 2 ampere is going away. What will be the current which is coming from here? Apply the Kirchhoff law. What will be the current from 10 volt source?
0. No,
Yes,
not 0.
very good. It will be 0 ampere. It will be 0 ampere. Okay. Yes, it will be 0 ampere. Now this is very clear. You apply the Kirchhoff law, you will get the answer. Okay, I'm not going to apply the Kirchhoff law here because Kirchhoff law, I'm not going to apply the steps. Just from the simple observation, it's very clear. It's very simple circuit. Now what will be the power for 10 volt? It is 10 volt multiplied by 0 ampere. It will be equal to 0 watts. So this guy is not delivering the power, not absorbing. He is just sitting idle, nothing. He is not doing anything. Now what about the power across the 2 ampere current source? It is 10 volt multiplied by 2 ampere. yes, 20 watts. And you can see here the voltage is minus and the current is entering. Since the current is entering, this guy is delivering power. Am I correct? Since the current is
Yes.
entering the negative terminal. So that's why this concept is very, very important. So the current is entering, that's why. Now, what about the 5 ohm resistance? We have 10 volt multiplied by 2 ampere. This is nothing but 20 watts. And this, you can see the current is going away from the negative terminal. So this is absorbing the power. Okay, it's clear?
Clear, Doctor.
Yes. Next, we will see another problem. Verify the intelligence theorem. 10 volt, and you have a current source which is 2 ampere, and this is 1 ohm. Okay, now we have to find what are the currents. Okay, sorry, what are, so we have to first find the power across the 10 volt battery and the power across the 2 ampere current source and the power across the 1 ohm resistance. Okay, these are the things we are going to find. So before that, you know that this is coming in, this is 2 ampere which is coming in, and this is 10 volt, and everything is parallel. Since it is parallel, the voltage across 1 ohm resistance is also 10 volt. So what do this? The current will go from positive to negative. That's why it is positive negative. So it is 10 ampere. Am I correct? It is 10 ampere. And you can see now this current is 10 ampere and 2 ampere is coming inside. So what will be the current from the 10 volt battery?
8.
It will be 8 ampere. Okay, we will see the power calculation. So you can see here this current is going like this, or it is entering the negative terminal because this is negative. So the current is entering the negative terminal. So it will be 10 volt multiplied by 8 ampere, which is equal to 80 watts. Is it delivering or absorbing the power? Yes, it is delivering the power. And what about the 2 ampere? For the 2 ampere, the voltage will be plus minus 10 volt. So 10 volt multiplied by 2 ampere, it is 20 watts.
Also.
It is also delivering. That's what the example that you have asked me, whether 2 sources can deliver. Okay. Now, another one, it is 10 volt multiplied by 10 ampere. So it is 100 watts. So the resistance is absorbing. So usually the resistance will be always absorbing. It cannot deliver any power, that you know, right? But the capacitance and inductance sometimes may deliver, because if it has the stored energy in capacitance or inductor, then it can release the energy, it can deliver the power also sometimes. Okay, not always. We will see those examples later. Okay, next example we will see. So what is the observation? So from all these problems, one of the observation you can say it is, if you have a voltage source and a current source in parallel, voltage source, let's say this is Vs, and you have a current source which is Is in parallel, then the voltage across these sources, the voltage across it will be Vs. Okay, this is very, very important point. So voltage across current source will depend, it can be anything, it depends on other elements in the network. Okay, this is very, very important point. So similarly, the current through the voltage source also will depend upon other elements. Okay, we have 3 more problems. After that I will stop the lecture. Is it okay? So just 3 problems, small ones.
Okay, Doctor.
So we will see what was the problem number. Yes, question number 4. Question number 5. Verify Tilligan's theorem. So you have a 100-volt source and you have a current source, something like this, which is giving you 2 ampere, and you have a resistance which is 1 ohm. Now you are going to calculate the power across the 100 volt and 2 ampere and also 1 ohm resistance. This is what you are going to find out. Now before that we will first find, so this current is 2 ampere, you know, and what will be the voltage across this?
100.
Yes, and what will be the voltage here? It is also 100. Okay, so what will be the current here? The current will be 100 ampere. Okay, so this current will be 100 ampere. Okay, now this current will be 100 ampere and this is 2 ampere.
Current from the source is 98.
We will apply the Kirchhoff law. Okay, just assume that your current is leaving from the junction. Assume like this. Okay, you can assume the current is leaving, because if the current is leaving from the junction, I can give positive sign. Okay, I can give the positive sign. So I will just assume plus I. Okay, then the current, this 2 ampere is entering, so minus 2 ampere. Okay, and this 100 ampere is leaving from the junction, so it is plus 100 ampere. This total will be equal to 0. So what will be I? I will be equal to minus
Minus 98.
98. So I am getting minus. You see here, I am getting minus. So my actual current will be,
Because of the direction.
yes, my actual current will be in the opposite direction. That's what I can assume actually like this. So my actual current is 98 ampere. So what will be the voltage, the 98 ampere? Now I am going to write the power across the 100-volt battery. It is 100 multiplied by 98. That is equal to 9800 watts. And 2 ampere, you have 100 volt multiplied by 2 ampere, which is 200. Yes. And 1 ohm, you have 100 volt multiplied by 100 ampere. It is 10,000 watts. Okay. Now what about this guy? You can see here this current is moving in this direction. So this current is entering the negative terminal, so it is delivering the power. And 2 ampere, you can see the current is moving in this direction, so it is entering the negative terminal. Again, it is delivering the power. And this guy, it is a resistance. Blindly you can say it is absorbing the power. It's clear?
Clear.
Yeah, just 2 problems. Okay, small problems. Question number C, verify Tilligan's theorem. We will see plus minus like this. So this is 5 ohm and this is 10 volt and this is 2 ampere. We want to verify the Tilligan's theorem. So we will calculate the power across the 10 volt battery, power across the 2 ampere current source, and power across the 5 ohm resistance. So for that we want to find the current. Actually the current, no issue, the current is 2 ampere everywhere, because you can see throughout the circuit it is 2 ampere, no doubt. So you can find what is the voltage here, plus minus 2 ampere into 5 ohm, it is 10 volt. And you can see here this is 10 across the 10 volt battery. You can say it is 10 volt multiplied by 2 ampere. It is nothing but 20 watts. And can you tell me, is it absorbing or delivering?
Delivering.
It is delivering the power. And next across we will calculate the 2 ampere later, and we will first next calculate the 5 ohm resistance. For the 5 ohm resistance you have 10 volt and the current is 2 ampere. It is nothing but 20 watts. Okay, 20 watts. Now can you tell me what is the situation?
The voltage across 2 ampere is 0, right?
Yeah, it will come like that anyway, we will see. Absorbing, right? This 5 ohm is absorbing. We will write the Kirchhoff law to find the voltage anyway. I will assume a voltage plus and minus like this, no problem. I will assume a voltage some V something. I will write the Kirchhoff law. So if I start from here, I can say the Kirchhoff voltage law, I can say here minus Vs, then sorry, minus Vs, minus 10 volt, then plus 10 volt, this is equal to 0. That means my Vs is equal to 0. So I have Vs, the voltage, this equal to 0 volt. So you can say here it is 0 volt multiplied by 2 ampere. So it will be equal to 0 watts. Is it delivering or absorbing? Nothing, because it is not
Neither.
delivering, not absorbing. Okay, we cannot
Yes.
write like that. So this is the problem. I hope that this is clear. Last problem. With this we will stop our lecture. This is question number 7. Okay, we have a 10 volt battery, 2 ampere current source in series, and you have something like this 1 ohm resistance. So we will calculate the 10 volt power across the 10 volt battery, 2 ampere current source, and 1 ohm resistance. Okay, so you know that the current is same throughout, so there is no doubt. You can see here. So when I consider the 10 volt battery, you can see the current is entering the negative terminal. Since the current is entering the negative terminal, this guy is actually delivering the power. Okay, so it is not, yes, 10 volt into 20 ampere, it is nothing but 20 watts. And this current through the resistance, it is going down, so it is plus minus, and the current is 2 ampere, you know, so 2 into 1, it is nothing but 2 volt. Okay, so for the 1 ohm resistance, I can say it is 2 volt multiplied by 2 ampere, it is nothing but 4 watts. Is it delivering or absorbing? It is absorbing the power. Okay, it is absorbing the power.
Yes.
Next we want to calculate the voltage across this current source. Okay, I can give the notation V2 ampere. Okay, voltage across the current source. So I will write the Kirchhoff law here. So Kirchhoff voltage law, I am starting from the position below. You can see minus voltage across 2 ampere current source, then there is minus sign, then minus 10 volt. Okay, then the voltage is 2 volt, so plus 2 volt, this is equal to 0. So minus V2 ampere minus 8 equal to 0. So voltage across 2 ampere is equal to how much?
Minus 8 volt.
Minus 8 volt. So actual polarity is different. You can see my assumption is wrong, so I have to change the assumption. It is minus and this is plus, and the voltage is 8 volt. So my voltage is 8 volt. Is clear?
So I cannot deliver. Yes.
So now you see the current is entering which terminal? You see the current is entering like this. The current is 2 ampere is moving like this. So we will first calculate how much power it is there. So power is voltage magnitude. What is the voltage magnitude? The magnitude of the voltage is 8 volt multiplied by what is the magnitude of the current? 2 ampere. It is 16 watts. What is happening here? Is delivering or absorbing? The current is entering which terminal? You see here.
The positive.
Relate to this. Yes. When the current enter the positive terminal, is it absorbing or delivering?
Absorbing.
it is absorbing. Okay, is clear? So these are the different types of problems. Okay, so inshallah we will see the next topic in the next class, inshallah, tomorrow. Okay,
Inshallah.
everybody is there. What about the other guys? Ryan?
Yes, Dr.
Doctor.
we are.
Thank you, Doctor. Thank you.